So this segment for us is possibly the section that some people say to start with, because at least if somebody drops this class, at least they'll know regular expressions. So regular expressions is the superpowered version of doing the find function. So if I open up, let's see, Visual Studio Code over here, right? And I'm going to go ahead and open up a file. Let's go to, and you can do this with Notepad++ or other basic text editors too. I'm going to go into our classroom file again. So let me go to a file we've already used. Classroom, ITP. And also forgive me if I have to look things up a bit in this, because I don't do regular expressions much with Python. My experience with regular expressions is doing them in grep or using them as part of built-in functions with Java, so I don't do it too much with Python. So here's our words file, right? This is a list of all the words in the English language. So if I want something, and if I want to find something in here, I just start typing abide, right? And it will highlight all the words that have abide as part of it. All right, and that's pretty cool. But notice that there's this toggle over here that says use regular expressions, and toggling that doesn't do too much. And if I do a period, it doesn't match anything. It matches all this stuff, all the acronyms that come with an A and a period. But as soon as I toggle the regular expression button, I get a lot more matches. I get A followed by anything. I get a lot of matches. So let's go ahead and kind of just demonstrate why we care about regular expressions. So it's one of my stories, and I hate to pick on somebody, but he was a well-known politician at the time. So this is Jeb Bush from 2015, and I've used this example before. Right? He as I said, for the sake of transparency, he basically released all of his emails as a governor. Okay. He dumped all of his emails as a governor, right? Released them to the public in an effort to be transparent. Unfortunately, you got emails. Unfortunately, included the emails that were sent to him and at his governor's email address. So some of them had confidential incriminations like this: Dear Governor Jeb Bush, RE da 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 SSN, which if you're not an American, you might not know what that means. SSN is short for Social Security number. Now Americans do not have a national ID system. We don't. There's this whole kind of this fear that basically if there's a national ID system, that basically the federal government will consolidate more power. But there's this opposition to that. And so a lot of times what happens is that we use our Social Security number instead, which is a number we use for social welfare program, Social Security, as an ID number. Now, it used to be that it said on the card, this should never be used for identification purposes. It doesn't have it on the card anymore because it was a losing battle, because Social Security numbers are pretty much used in lieu of a national ID, and it's terrible that that's the case, but because it's not a very good number. But anyway, you don't want to send this number to anyone. Here he sent it to the governor of his state because he was thinking, here I am, you can identify me by my Social Security number, maybe look that up to figure out who I am, and solve the problem I have. Or here, right, this is a patient we're trying to get medical care for. Can you possibly step in this case, Governor? Here's the Social Security number, right? So it had a lot of Social Security numbers in there. That's not, and the issue is that they released all the emails without really reading them all. Now, mind you, these are a decade's worth of emails. Even granted that basically from the 90s, the email wasn't necessarily used too much. By the 2000s, they were. So, and looking for an email is, looking for a Social Security number in this document. Let's just go ahead and just place one just randomly in the document, right over here, 777-77-7777. And I'm sorry if you have that social security number and I just put it on the board. I somehow doubt that you do, but that's but it's quite possible. So anyway, social security numbers are always of the format 3 numbers dash 2 numbers dash 4 numbers. Now let's go back to this up here. So this is tracking where I made a change to the file, but now suppose that this is basically our email for some reason, and for some reason somebody included their social security number in it. How in the world do I find such a thing? Right? I can't, if I want to, as far as I can tell, maybe I can check every string and say, maybe I can write a program and say, okay, check each word on this. If the first thing is a number, go to the second character. If the second character number, go to the third character. The third character number, go to it, and so on and so forth. It's a very tedious program to write. I'll show you the program that they wrote to try to find a telephone number. But with regular expressions, and my face is blocking the little toggle switch, which I'm going to hit right now, I can do something like this. Find a number. That's followed by another number. That's followed by a third number. That's followed by a dash. So I just typed in /D/D/D and then a dash to find it. Now the nice thing about this, if we go and open up Word, right, let's go ahead and just kind of show you. We'll grab this small section. We'll dump it into a blank document in Word. Okay, and now we'll do the find and select Advanced Find. More. And now I'll select Use Wildcards. Find what? So I can find stuff like pre in here, and I'll go through. I want a pre-file. So now I want a pre. Let's see. I want to find the string followed SU followed by an R or a P. It's a bit hard to see, but I've got it surrounded by brackets there. So it was SU bracket R or P. So it found survey, wrapped around to sup. So now I can do an optional search over here, and I can also search for a digit. /D/D/D dash. Let's see, does it find it? No. Okay, I thought it did. Why doesn't it find it? I thought you can do regular expressions in this thing. But did the wildcard matching. Interesting. So I thought regular expressions worked in Word. Like I said, I don't use Word like ever. So, but it's a powerful tool that we can use here. So what are regular expressions? Okay. So the example they use are phone numbers, American phone numbers, right? Which are digit dash. So it's 3 digits followed by a dash, followed by 3 digits, followed by a dash, followed by 4 digits. So it is essentially 10 digits separated into groups of 3, 3, and 4. Right? So regular expressions, it says Microsoft Word and OpenOffice have find and replace features that you can use regular expressions for. So these are huge time savers. Right? So we can find regular expressions. So they're gonna start by showing you how to find a text pattern without using a regular expression, and then they'll show how using a regular expression makes it much shorter. So let's say we want to find a telephone number that's a string. The pattern is 3 numbers, a hyphen, 3 numbers, a hyphen, and then 4 numbers. So here's the phone. Here's his. This is the program that he wrote to do that, right? Without using regular expressions. So taking a string, if it is not 12, so if the phone number is not 12 long, return false, right? Because it's 10 numbers and 2 dashes. So if it's not exactly that length, then it's not phone number, right? For I in range 0 to 3. So if 0, 1, and 3 are not if index 0, 1, and 2 are not numbers, return false. If this is not a dash, return false. If these are not numbers, return false. If this is not a dash, return false. And then finally, if these are not numbers, return false, right? So see how all those clauses are basically checking every individual case like with an if statement. That can get very tedious. Otherwise, return true. So if you run this program, it'll print out that 415-555-4242 is a phone number. It'll print out true. But if you try checking if Moshi Moshi is a phone number, it'll print out false. So it does a lot of checks to make sure and check if it's a telephone number. So now we can actually check, do something like this, like to make sure that a chunk of text is a telephone number. So for I in the range of the length message, chunk is grab this I through I plus 12. If that chunk is a phone number found. So here, running this program with the program that you just wrote, you can find a chunk of text and say, hey, that's a phone number. Hey, that's a phone number. Print them both out. But it's a lot of code to do something very simple. So it's 17 lines of code to find just one thing. So we're going to reduce that. So we're going to use regular expressions. And so that only matches. So the issue with this is that it only matches things that are for, if you do number dash number dash number. But what if you do dots instead of dashes? Or if there's the actual way that phone numbers are listed in America, which is parentheses for the area code followed by that. Or what if you have an extension number? The is phone number will fail on that. So regular expressions, though, are much easier to build. So regular expressions, or regexes for short, are just simply descriptions for pattern matching or matching patterns in text. Now there are limits. There are very hard limits on what a regular expression can do, which are best described with the following. The limitation of a regular expression is that it's unable to have any memory. Okay? It has no memory. So if it needs a memory to do something, then it's not going to work on it. An example of where a regular expression will fail, or you can't, by fail, I mean like regular expressions as a concept will fail you, is when you're trying to do something called parentheses matching, where basically you're trying to say, okay, do we have, enough parentheses, are the parentheses balanced in this expression? Regular expressions really can't do that. Okay? And we need more advanced languages to do that. So a regular expression is kind of related to languages, which is an entirely linguistical thing that I'm not even going to go into, because that's something I learned in a 4,000 level class that was taught by a very tired PhD student. But it was very, very interesting. So there are short descriptions that you can use for text. So /d in a regex means that it's a digit. That is any number from 0 to 9. So /d means digit, dash, then 3 more digits, dash 4 digits. So, but you can also make them very sophisticated. For example, by adding a 3 in the curly brackets in a pattern is saying match this pattern 3 times. So we can say the same expression by doing this. /d exactly 3 times, followed by a dash, followed by exactly 3 digits, followed by a dash, followed by exactly 4 digits is a correct phone number. So how do we use these things in Python? So to follow me along, either in the shell or in a program, you will need to use regular expressions, you will need to import the RE. Okay? So every time you restart you write a script that's using regular expressions or testing stuff with regular expressions, you need to remember to import RE. Okay? So the first thing you need to do is create the pattern you want to match using the re-compile method. And it returns a regex pattern, or what we're just going to call regex, a regular expression. So you create a regular expression. And then you can use that to match strings. So let's go ahead and start by doing our phone number test. So def phone number test. Right, and I've imported RE at the top there. Ignore all this. It doesn't matter. I was using that to make sure I understood that. So the first thing it says to do is that we want to compile our regular expression. And I'm going to write our regular expression as note the R for raw string, which means that, so just follow me for a second on this. 3 Ds followed by 3 more Ds followed by 4 Ds. And I'm going to give it a text over here to pass it in. Actually, forget that for later. So how many is Japan? It's 344. Do you want me to use Japanese phone numbers for you guys? Doesn't matter to me. About the same. Okay. So now, that's how we create a regular expression object. So how do we do that? Well, then we can do a bunch of other things with it. Why did I use the R at the front? If I don't have the R at the front, remember that the backslash needs to be escaped. So if I didn't use the R over there, I'd have to be doing something like this. I'd have to be doing 2 of these backslashes together in order to do that.
What does R mean?
Raw string. Meaning that take the string exactly as is. You know, backslashes and all. Okay. Now how do I actually use it? Okay, so what it does is that the regex has a search function, or method rather, that searches any string that's given to it for your regular expression. So let's go ahead and do search. We're going to search this string for it. This is my fake phone number, comma 123-456-7890. That's my fake phone number. Yes.
What will that give out?
So let's see. So regex-search, we're going to want to save it into something called a match object. So it gives out a match object. mo.group. And then we print out the group. Let's go ahead and see. And now if we run this by actually running phone number test, it says 123-456-7890. Notice that that's the string in here that matched the telephone number. So now I'm going to put a period by that and say, got it? Question mark. Notice that basically by doing this, we are extracting the bit of text, right, that has the telephone number in it. Okay? Let's go ahead and up this a bit. I'm going to add 2 more quotation marks, right, to make this a multi-string. You know, my fake number, my burner is 08 is this, right? Doesn't matter what your number is there, just I'm doing it in reverse. And now if we run this again, it prints out my fake number is this, and then it doesn't get the other one.
I'm getting Mo is a non-type with no attribute group.
Mo is a non-type. Are you using Python?
3.6.5.
Did you import RE?
Yep.
Did you do regex.search?
Yep. Mo equals regex.search.
Let's see very quickly. Oh, well, it didn't find find it in there. That's why. So you're getting a none. Okay. So if it finds it,
I didn't get anything.
did you print anything out? Did you call the method? Did you put in a method and did you call the method?
Oh.
I almost forgot to do that myself. So, all right. So okay. So you compile it, you search it, and then you can grab the group to print that number. So to match stuff with regular expressions, you import RE, you compile it, the pattern you want to use to find it, pass the string into the search method, and that will give you a match object. And then you can get a group, use group to get the text that was matched. So there's, let's see. So another cool thing you can do is you can group parts of the regular expression, and split it up parts that you're matching. So notice that adding that here, we're going to add So first off, let's see. I'm going to delete with the burner because I know exactly what's going on now. Okay, what's cool about this is I can do this. I can put parentheses around there and create what's called a group. And now, if I run this again, still,
Put it in between each. Why don't you group the first 3 digits?
Because the first 3 digits are an area code, right? And now what I can ask is I can print out the group to print out the whole thing together, but I can also print out group 1, which is 1, 2, 3, the first group, and then the second group is 4, 5, 6, 7, 8, 9, 10, 0. So now notice with the parentheses I can group them together. I wonder is group 0? It's the whole thing, right? The whole thing is group 0. Group 1 is the first part. Group 2 is the second part. So you can get specific parts of a pattern too by grouping them together. Sorry? You can. You can. So we'll get into that in just a second. So give me 1 second. So now I can do something like this. Print. Let's go ahead and make this more usable. Print mo.group. So let's go with number. So let's go ahead and say phone number. And I'll need a comma here. And then if I do just group 1, I can say area code, comma, group 1. That's nice, ain't it? All right. So again, we're following this one. If you want to grab all the groups at once, you can just do print mo.groups to get all the groups together. So here it gives you 1, 2, 3, and then 4, 5, 6, -7, 8, 9, 0. Right, everybody see how using groups instead of group gives you all the regular expression, all the groups together. Now, I typically don't use groups, but it's a nice thing to have. So groups is useful, but what if I want to actually search for something that actually has parentheses around it? Then we'll have to escape it. So so now notice with my expression, I have to have a literal parentheses. I've escaped the parentheses, and I've escaped the closed parentheses. And now if I do, now it needs to be this way in order to match. Right? How I've escaped the parentheses in order for it to find the parentheses. So that's one thing that you'll have to be aware of. But there's a lot of options for finding regular expressions. Okay, so before we get into like the ands, ors, and stuff, right? Let's just go ahead and say, what if I want? Let's go back to our original example, like def. So let's try what we use for def is Japanese or American number, right? This will be taking a text, right? And now we're going to check, is this thing a Japanese telephone number or is it an American phone number? Okay? It will match either a Japanese or American. We'll be able to tell us if it's Japanese or if it's American. It's just going to match either of them. Okay? Or it might be able to. Let's go ahead and see. So the regular expression I'm going to compile, let's start with the Japanese phone number. Sorry, with the American phone number. So let's go ahead and start. The American phone number, right, looks like this. It's three numbers. So let's go ahead and do 3 numbers, right? Followed by a dash, followed by 4 phone numbers. Sorry, followed by 3 numbers, followed by 4 numbers. Right? What's a Japanese number look like? 344. So Japanese phone number is /D followed by 3 numbers. /D followed by a dash, right? Followed by 4 phone number, followed by a dash, followed by 4. So this is saying. So now let's look at what this bar is. So you've got a Japanese telephone number is either 3 numbers followed by a dash, number is either 3 numbers followed by a dash, 3 numbers followed by a dash, 4 numbers. Or we're looking for something that's a 3 numbers followed by 4 numbers followed by 4 numbers. Okay, so MO is equal to regex dot search. I probably could. Let's see. You mean split them up like one in the other parentheses. Like so? Let's go ahead and try searching text though, and then we'll go ahead and let's go ahead and print mo.groups and see what we get. Because let's go ahead and use this. Again, I'm much more comfortable using these in using something like grep. The number is 777777. So now if we run this, none in the first. We didn't find anything that matched the first pattern, but we found something that matched the second pattern. So that does let us know that we found a Japanese number in there. What if we do here is my number. Do 3. Or so doing 4 numbers now over here. And so notice that it doesn't find the second number. Now this is because that regular expressions are what we call greedy. It finds the first possible match and returns it back to us. So we'll figure out how to do with that now. But let's go ahead and now talk about like the rules of regular expressions before we get into more of more things. All right, what can we do with regular expressions? Okay. So you can match several patterns. I like this example. Try this out on your compiler. A bat regex is equal to our regex that compile the raw string bat, man, mobile, copter, bat. And then you can search Batmobile and it will match Batmobile. Right? If you get this first group in there, it will find mobile. Right? But notice this will match Batman, Batmobile, Batcopter, or Batbat. Right? Because it will match bat followed by a man, a mobile, a copter, or a bat. That's pretty cool.
So if you have multiple, like, Batman left his Batmobile.
Yeah.
Or like that phone.
Yeah. Yeah, Batman left his bat phone in the Batmobile. It will find that. So what we can do to do that, so to fix that problem, let's go ahead and turn that into an exercise. So Batman text, and this one will find all the text, all the bat text in the bat string. Okay, so let's go ahead and say what our regex is. Regex is, we want basically the bat. So what kind of Batman things does he have? He typically has a bat. So it could be Batman, right? We could also, and he has, as you said, the bat phone, which he'll probably leave in the Batmobile. He also occasionally has bat shark repellent, right? True story of Adam West. Yeah. Come on. Oh yes, thank you. Not shark repellent. Okay. So now this will return a list of all the bat words, whatever that is. We don't have bat words yet. So let's go ahead and write regex. So let's go ahead and say regex dot search text, right? And that's going to turn a match object. So I can do and then say, but instead of doing a search, I can instead do regex dot find all in text.
So what's the difference between find all and
search to the search one? Find all. Let's see what find all does. Batman. Okay. Batman left the bat phone in the Batmobile. Okay, and now if we print the output of this, it returns man, phone, and mobile. So it returned all the group 1. So it found that it had man, phone, and mobile in there. So let's see. Can we do find all returns regex dot. So again, regex dot find all returns essentially a string that matched all of this. If I wanted to return, so again, I'm going to have to what? Yeah, it didn't return Batman, Batphone, Batmobile. It returned man, phone, and mobile. Yeah, return batwords. All right. So one new thing that's useful is that you can have an optional. So we'll go back to this, but for right now, we're going to focus on finding one thing right now. The group. So optional character matching with the question mark. Here, for instance, we've got bat regular expression re.compile r bat woman. Right, we've got the woe over there with the question mark. Bat regex search the adventures of Batman, and it returned Batman. Right, notice how we're searching the adventures of Batman for Batwoman. So this question mark means that the group that precedes it is optional. So the WO in there is optional. So it'll match either so we'll find text in either Batman or Batwoman. Make sense to everybody? All right. Another similar one is using that for the area code over in our area code. So here we have a group for digit/D/D/D dash, right? What if the user leaves out their area code? Well, we can put a question mark around that. So it'll match just with the area code or without. So you can think of the question, it says you can think of the question mark as saying match 0 or 1 of the group preceded with it. So the star asterisk, so the asterisk is actually also very special here. It's technically called the clean star, for spelled K-L-E-E-N-E, the clean star, okay? But you can just call it the star, right? Because that's easy to remember. Now, that is not a literal asterisk. It's a special symbol of its own in regular expression, okay? It means 0 to infinite number of these. It means 0 or more of this preceding group. And if you don't have a group, it's 0 or 1 or more of the preceding character. So, one thing I like to show off, which I think will be a bit quicker, is I like this for this website, regexer. Okay, for doing regular expressions, and I'll have to zoom in a bit because, of course, you know, yeah. Let me go ahead and zoom out a bit more. Okay, so for example, here's how a clean star would work. Okay, say I want to find A followed by any digit followed by an A. Right, so this is like, this will match A2A, A3A. It's like, again, this is like ridiculous text that doesn't actually exist, okay? But say I wanted to find any number of an A separated by any number of digits followed by another A. So the pattern I have here matches 2 A's. It matches A2A. It matches, you know, a bunch of A's. Matches no A's, but it doesn't match this because we're looking for any number of digits between them, right? Make sense to everybody? So the star operator says, look at the group before me. I want at least 0 or at least 0 of those. Okay? So in this case, right, the group, and if you don't have a group, it's just simply the string before you. So batregex is equal to the adventures of Batwoman. So we can take this over here and, you know, our regular expression dot compile it. Let's go ahead and boot up idle. I think is going to be much more. So let's go ahead and yeah, leave this page. I hate it when that happens because, of course, I'm running 2 screens. So so first off, if you're going to be doing this in here, you got to do import re is equal to re.compile. R, and then the important part of this is the bat whoa star man. Okay, so mo1 is equal to bat. Yeah, I'll copy it and paste it. Copy the adventures of Batman, right? And it will match that. Mo dot. So if I do mo1 dot group, it'll match the adventures of Batman. But if I were to do this for, say, mo2 is equal to batregex dot search, if I were to do the bat wow woman, right? mo2.group. It matches that just fine because it looks for bat followed by as many WOs as it wants, including 0, and then followed by a man. Okay? So that's 0 or more. Typically, though, you don't want 0 or more. Typically, you want at least 1 of something, which is where the plus comes in. So plus means match at least 1. So this one won't match Batman. It will just match Batwoman or Batwoman, right? It won't match Batman, though. Make sense to everybody? And we've already learned about curly braces using repetition, meaning do exactly these things. So ha3 will give you ha ha ha. But it will not match ha ha because that's 2 ha ha's, right? It will match 3 ha's together. That makes sense to everybody? Ha. So what you can do is you can specify a range. Ha curly brace 3, 5 will match. Yeah, regexer is definitely the better thing to do here. Regexer. Right? If we use this, ha 3 to 5, it won't match 1 ha, but it will match 2 ha's. Well, sorry, it won't match 2. It will match 3 ha's together, but not, or 4, or 5, but not 6 ha's. Why not 6 ha's? Well, because we specified we want 3 to 5 ha's. If I wanted this one, it matches exactly 3. And notice here it's got 2 groups. It's a bit that matches the first ha-ha and the second ha-ha. Okay, with that in question, if I switch this to 1, 3, what is it going to match? It's going to match, again, 2 groups of 3 because it's looking for as big of a pattern as it can match. It's greedy. As opposed to 6 individual ha's. Alright. So, yep, just getting at that. It's 3 to ha can match. So again, it gives you back, if you did 3 to 5 on here, it will give you ha 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 instead of the shorter possibilities. It's greedy by default. If you add in a question mark, though, you can make it be not greedy and have it find the shortest possible string. So if you add a question mark over here, again, on the end, it's going to go for the shortest possible thing. Now, why does this work over here, by the way? I'm not working in Python. Why does it work over here? Because the rules for regular expressions are based off off of Perl's regular expression rules. And that's pretty much the one that's been dominant, like, forever. So regular expressions are basically the same from one programming language to another, to one application to another. Okay. So, all right.
You use that a lot in formatting for Excel.
What?
Like this style of
Regular
slash digit and all that stuff.
Yeah.
For Excel.
You can use it in Excel?
Yeah, so like when you're trying to format dates.
Ah. Yeah, find what? Options. Format. Can...
In the date, yeah, if you click on it, it'll show like...
Ah. So, find format.
You can also create your own, and that's where...
Let's see. So let's go ahead and see. So it starts looking for that. So find what? 3 dot. So where would I find that? Create your. Or is it just under format? Again, I don't use it.
So right click any of the empty cells like go to the and right click and you can format the cell on the near the bottom. Yep.
Mm-hmm.
And then you can go on the bottom to custom.
Ah.
So then yeah.
Ah, yes.
There you can
So similar stuff. I assume this means number, comma, number, number. Yeah, there's similar stuff using in here. Because regular expressions can get really, really strong. So here you also have the find all, right, which we were looking at initially. mo.group gives you the, so find all will find all the things that match that regular expression. If there are groups, find all will return a list of tuple. Each represents a found match and the items in here. So here's the first screen. Here's what find all does. If there are groups in find all, it will return basically each part of the group. So remember when we did our Batman example over here, it just simply returned man, phone, and mobile. If I put bat in its own tuple, it will return Batman, Batphone, Batmobile, right? So it returns basically. So find all is kind of useful because you often want to find all the things in something that match this pattern. If I didn't want to use the tuples though, I just want the whole thing, I would have to do Batman, Batphone, Batmobile, Batshark repellent. Unbalanced parentheses. And now run it. Batman, Batphone, Batshark repellent. Right? And remember, this is the or separates individual regular expressions that basically you can find. So what are some common rules now? So other things we can do. So this is kind of the most useful part of it. Because these are, before we get into the last 10 minutes where I go over the homework, which will keep you occupied, I think, well into tomorrow, hopefully. You've got /d. So /d matches anything that's a digit, right? /d matches anything that's not a digit. That's useful. /w is anything that's a letter, a digit, or an underscore. So think of it as a word, something that's not punctuation, essentially. Something that could be part of text that you would actually read and digest. /w matches anything that's not a letter or a digit or the underscore. So think of things like spaces and punctuation. /s is anything that matches spaces, tabs, anything that's white space. And /S is anything that's not white space. My personal favorite, though, is being able to find, is using basically the brackets. So, which is like this. Match anything that's A, B, C, D, or E, followed by an R. So, created or right? So the bracket says anything between the brackets match exactly one of. And you can even use stuff like an asterisk in there, and it will literally interpret the asterisk. Same with the parentheses over here. Make sense? So the bracket literally means find any one of these characters. Although, even cooler, you can put a not over here, and it will say find anything that's not A, B, C, D, say A, B, C, D, or E, followed by an R. Yes. Yeah.
So, when we use these regular expressions to find things, we then store them into variables, right?
Right.
If they don't find anything,
they will return a none.
A none. All right.
And so it returns a none. So what is a none? A none literally means it is nothing. A none is nothing. Print. None is true. None is not true. None is not false. None is not one. None is nothing but none. None is none. Okay? None means basically it's the absence of any data. Okay? Does that make sense? Mm-hmm. It's different than an empty string or an empty list, right? Because that implies that there's at least a list you can do something with. None means there's nothing there. It's like It's like null in Java. It's exactly what it is. Okay. So another thing is, though, that these character classes is that you can also use. It works exactly like you'd like it to. So A-E means any A through E. Capital A through E. Okay. And one more important thing is that these are yeah, so you can make your own. So here's like looking for all the vowels. RoboCop eats baby food. Baby food. O-O-O-E-A. So he finds all the vowels, uppercase and lowercase. That's pretty cool. Python does have case insensitive. Let me just go over to here. You have to put it somewhere else though. Yeah. Yeah. So to make it case insensitive in Python, you have to do comma. You have to say re-i at the end to make it case insensitive. Okay. So like over here, RoboCop equals recompile RoboCop. Then notice the comma re-i. Search RoboCop is part man, part machine, all cop group, and it will print out RoboCop. RoboCop.search. RoboCop presents the innocence, which will give you RoboCop in all caps. RoboCop.search. Al, why does your programming book talk about RoboCop so much? Dot group, and it will give you, and it gives RoboCop in all that. So let's go ahead and talk about the homework assignment that I wrote up for you guys, which is multiple parts, but I feel like it's worthwhile to get good experience with regular expressions, and and believe it or not, it will be something I work alongside with you too. So let's go ahead and look at our assignment. Your second exam will also, because I can't really think of too many other things to cover, we'll cover lists, regular expressions, and I don't know when that will be. I'll give you at least a week's notice before I give you an exam date, but I'll look at the calendar.
That's the only exam, right?
So there will be exam 1, exam 2, and a final. So, okay. So I've got 4 pages of assignments for you, although as you can see, a lot of it's blank. So the first part is I give you a dictionary file. Okay? And it's a file, basically, it's words.txt. It's a file full of a bunch of words, literally. Okay? It is basically like an English dictionary file that your computer would use. Okay? If you're using a Unix system, like if you're using a Mac, feel free to use the dictionary in your own computer, which would probably be located in something like //user/ /share/dict. And if you've got a dictionary file installed there, you can use it, okay, instead of what I give you. So please give me basically the regular expression you use. So you don't have to use Python for this. You could use grep instead if you know what it is. But I suggest using Python for the most part for the answer to these questions. So here are your questions. I like animals. How many words contain the word cat or dog in them? So here, obviously what you want to do is compile a regular expression, use the dot find all to give me the list. Sorry, not necessarily to give me the list, but then you can, once you have the list, you can use length of the list to tell how many have cat and dog, and you can look at the list to find what they are. 4-letter words are supposedly naughty. How many 4-letter words are there? Okay. Do more words end in ing or ion? How many words contain a Q not immediately followed by a U? Right? In the English language, you have most words like question are Q followed by a U. But Q isn't always followed by a U. And not every Q, like not every word also begins with Q. So how many words actually have a Q that's not followed by a U? That's a pretty simple regex over there. How many words have no vowels in them? How many words are there with 2 vowels in a row? How many words with at least 2 vowels are there? The vowels do not need to be adjacent in this case. unlike the so that's the trick here. It's not just AA, BB, CC. It's how many have at least 2 vowels and they're not adjacent to one another. Okay. If you're having trouble, please click on this link. I hope it's not broken. And it's the website I was using, right, on regular expressions. And notice over here it's got references on how to use it and stuff, and a cheat sheet of all the things over here. Most of what we've went over. We haven't gone over everything, so I don't necessarily expect you to start this tonight or anything. You can. I expect you to start it maybe on Thursday after I go over more on regular expressions. Okay. The second part is more regular expressions. Writing more regular expressions. The third problem we're going to do is write a program that detects whether or not a password that somebody creates is a strong password. Right? Those meet those password requirements. 8 characters long, contains both upper and lowercase characters, and in 1 digit. And then we're actually going to write a useful program that actually is, if you have to make a password for someone. Using that kind of password is a bad design. Read the comic to find out why. Which is to just create a bunch of random words together, because that way they're longer and easier to remember. Write a program that combines 4 words that are of each 4 letters each into a single password. Okay, so that's the next homework to do. All right, so I think that's good for class today. So we will resume regular expressions when we get back.